guys, so this is Yuri. I'm here today to show you a simple structural software analysis. It's called the F2. And today this is a brief tutorial on how to use the software and for academic and even professional purposes. So the name of the software is called the F2. Okay, you can download on this link, which I'm going to let on the link below. So you can actually go through the web page, okay? The F2 software is actually a very lightweight software. You can use it for some assignments, you can use to study, and much more. The F2 is actually a Brazilian-based software. It was developed by Luis Fernando Marta, which is one of the best professors here in Brazil on the matter of structural analysis. He wrote a few books. One of them is this one, Analysis of Structures, Concepts and Basic Methods. You can only have the Portuguese version, but you can also encounter a few other textbooks in English related to the subject. Today I'm going to show you a little bit about the F2. The F2 is a two-dimensional frame analysis tool, which means we are just going to build up a 2D structures. You can create trusses, beams, and even frames. The interface is actually extremely friendly. Here at the up part of the software, you can click on Files, Option, and Display. In the options part, the first thing that you need to do is set up your units and metric systems. You can put up the international system, which is going to be based on meters and kilonewtons. Meters is going to be the unit of length, and kilonewtons is going to be the unit of force. You can also create a kilonewton meter unit system, which is you're only going to be using meters and kilonewtons. The SI, you can actually see the displacement, for example, in millimeters. Okay, you can see other parameters such as temperature in degrees Celsius. But also the F2 comes up with the US metric system, where you will see the length in feet and inches. You can see forces in kilopounds or even pounds. And your temperature, it's going to be on Fahrenheit. In this video, I'm just going to use the SI system, which is what we use in the rest of the America and the Europe and the rest of the globe. I believe only the United States and a few other countries that use the US metric system. After that, you can see the other parts of the interface. Here at the top, you can put up the material properties, so you can tell the F2 what materials you're going to use. You can declare steel isotropic or concrete isotropic. The second part is section properties. So you're going to create a section, can be a square section, a rectangle section, an I shape, a previous I shape from the industry. The F2 comes with that. Here on the right part you have support conditions. So if you click in each one of the subjects, on the right part of this is going to change. So here are the support conditions. You can literally strain the displacement in X, XX, YX, and the ZX. The ZX is actually the X where it's coming out of the screen, let's say that. You can actually put also springs into your restraints, okay, to simulate, for example, a spring for foundations design and purposes. On the right part, you will have the connections displacement. You can let your structure have articulated connections, which is pretty much a pin connection. You also can get a fully restrained connection for your structure. Okay, here we are going to be using only fixed connections, but when we're designing trusses, for example, you can let it free the rotation of a few members. And here you can also put the deformation restraints. You can make a member flexible or not, and you can let a member to be axial or sheared, related, exposed. Here on the part you can place also nodal forces, members, and moments. You can put up uniform loads and triangle loads and plus temperature loads if you like to assess the influence of heat in your structure. Also, there is load train, so you can actually assess the loads where there is movement in your structure. This version here of Ftool is actually for academic purposes, so it's a free software. You can download it for free on the page that I showed you before, but there's also a paid version where you can put load case and load combinations. On the right part here, you will see the scale. Okay, you will see also the envelope results, and you can also see the influence line results. Here in the right part, you can see the diagram of internal forces, such as axial force. You can see shear forces and bending moment. Okay, also here on the far right part, you will see the form configuration. Each Ftool command window creates only one structure, but you can create multiple structures in the same grid area. Okay. On the right part here, on the bottom, you can create the grid line. The grid line is going to be placed the dots in a specific lengths. I don't know if you can see very well from my command window here, but the dots are spaced from each other 1 meter apart. If you click on the snap option, such as the AutoCAD, whenever you are clicking to create a frame or a bar, the mouse is actually going to be attracted to each grid point. Okay, so in this example here, I'm just going to create a simple beam, which is going to be a beam with two support conditions. Here on the left part, you can insert the dimension line explaining and showing me how long that section it is. Here on the display, actually on the option size, I'm just going to increase the size of the support conditions, the load displacement size, and also I'm just going to increase the text displacement size so we can see it better from my command window. Well, after you design the length of your beam, we can also put the support conditions. So on the far left side of the structure, I have to select the notch, and then I'm just going to put a pinned condition support. If I click there, well, it's going to assign to that notch. If I select the other notch and put, for example, free on displacement in the X, it's going to put a roller support condition. That means this is a fully determined structure, and here we are not going to have any displacement on the x nor the y-axis. Here we're not going to have a displacement on the y-axis, and we can have displacement on the x-axis. If you can also select different support conditions to that personal application. You can actually have some fun here. For example, I'm just going to do a fully fixed condition. So you can pretty much work with anything that you wish for, and you can create any types of 2D structures. Well, after we're done building up our structure, we have to declare what materials we're going to use. So here on create new material properties, I'm just going to create a new property called steel. Here it comes up already in the software. The default steel is isotropic. If I click in done, it's going to pull several properties that we are usually seeing on steel. Okay. If I was to create an aluminum properties, it would also pull up different types of mechanical properties. Here we have mechanical properties and thermal properties when we want to create a thermal load. But since this video is actually a very simple tutorial, we're just going to make an analysis on a static load condition and on a structure that is actually really simple. So I select my frame and I assign that material property to every single bar of my structure. Next, I'm going to create a section properties. If I don't create a section properties, the Ftool is not going to run, okay? So here, for example, I can create a rectangle shape, an I shape, a Z shape, a Z shape, a circle ring, etc. You can also create a steel section that comes already in the industry. So for example, here I can create an American industry shape, all right? But here in Brazil, for example, BR Brazil, we actually have several industries that they build up different sections, and one of the famous ones is the Gerdau. I click it done. Oh, actually, I have to put up a name. Let's call it here a W200 by 22 point. I think it's 22.3. I'm not sure, but let's see. I click on done. It's going to bring up several I shapes. Have an I shape, a H shape, and PL for an English shape. The I shape, actually, I check for the 200, and then I move to the right here, and I will be looking for my section that I declare. Here I missed by 0.2, so it's 22.5, and I declare 22.3, but there is no problem at all. All right. After I just clicked, the last thing that I clicked, it's going to build up my section with that section properties. Here we have the length, the total height of my section, the web thickness, the flange width, the flange thickness, right? It also calculates the geometric center, the area, and the inertia. You also can rotate, if you like, your shape. And then when you rotate, it's going to calculate the smaller inertia, okay? And after that, I select my frame, and then I click Apply to All. All right, so I finished applying. And last thing, we can also put loads. So here, I click the nodal forces. I am going to create a nodal force called, let's say, P equals minus 10 kilonewtons. When I click that, and I click done, it's actually going to ask me the magnitude of that force. Here I have to put minus 10, so the force is going to be upside down. If I select a notch and put apply, the force is going to be pointing to the bottom of the screen. If this was to be positive, then the force it would be on the up yard, right? Means that the y-axis going up it's positive, and the x-axis going to the right is positive. So here, let's just place in 9. I also can create another load, for example, a horizontal load equals to minus 5 kilonewtons. Clicking done, and then I'm going to put here minus 5. And then when I select the support and click apply, the force is going to show it up. You can also put different multiple forces in one notch. Let's say here I can put also a minus 3, and the minus 3 is going to be placed on that notch. You can also put a concentrate moment. Let's say, just say here 2, and then that moment is also going to be showed up. But here, yeah, let's just leave it right there. And also, I can also put a concentrated moment in one of the support conditions when, for example, we have a cantilever beam, and we are putting a fixed condition. You can place that as well. Here, let's going to put a distributed load. Here I'm going to put a load called Q equals, let's say, minus 3 kilonewtons per meter. I'm clicking done, and then I'm going to put minus 3 here and apply to that bar. That distributed load is going to be showed up as well. So the Ftool is actually a very easy and friendly environment software where you can pretty much assess your structure for different types of loading. After that, you should click save. Let's just say here test 1. And after my structure is saved, I can assess the influence of these forces for the section that I have chosen. If you click directly on one of the icons that shows the internal diagrams, the structure is going to automatically run, okay? So here I'm also going to ask them to displace the reaction forces plus the reaction values, all right? So if you analyze the structure, for example, on the horizontal x, you have the force -5 here. The -5 is actually going to compress my whole beam. So when I ask for the F2 to show the actual forces here is going to be -5 because it means it's compression. If that force is actually if that force was actually positive, let's go back to it and change the -5 to +5. That force is actually going to pull the structure, and the actual force is going to be a tension, so it's going to be a positive stress. Right? So let's go back and change that to -5 again. Okay, it shows me the actual diagram, and I can increase the scale of it, and so I can also see the shear forces. Okay, shear forces from the section up it's positive, from the section below it's actually negative, so you can see the values here. So you can also increase the size of your shear diagram as well. And lastly, you have the bending moment. It's actually interesting because the bending moment, if you are an American, you would say that that bending moment is actually wrong. But it's actually really funny because I myself I studied in the University of Colorado in Denver, and there I've learned that in the United States the bending diagram is actually contrary from the rest of the globe. If you check the bending diagram in Europe, in Brazil, and other Latin countries, you will see that the bending diagram is actually the opposite from the United States. In the United States, this is actually an American book from McCormack. It's an amazing book. But here it shows that the moment diagram is actually positive on the top part and negative on the below the beam section. So if you are an American student, whenever you are checking with that software, the bending diagram is going to be the opposite. But if you're an European and you're just studying the software, well, this is going to be normal. So here you can see, for example, let me just erase the lines, and let's place again and increase the value. So you see that there is a discontinuity on the support because of the concentrated moment. And here, where there was a distributed load, your diagram is actually, there is curvature here. So it's actually a second degree equation. Whereas after that, the first notch, you have a linear equation because you have just nodal forces. And lastly, you can also see the displacement of your structure. Actually, this displacement is extremely exaggerated, but is an example of how your beam is actually going to be performing. Another interesting thing is that if you click in any part of your beam, you can collect information of that specific notch. So if we were going to assess the bending moments, if you click in any part of your beam, you can actually see the value of that bending forces and shear forces and etc. Going back to the displacement, there on the right side here, there is actually a arrow. If you click there, you can see your diagram without any values, which is the first case, which is what we're going to see right now. And also you can click there to show you your horizontal values. Okay, so it appears in each notch and plus here. Okay, remembering that based on the units that we have chosen, displacement is actually millimeters. Okay, so this is actually a horizontal value of minus 1.68 times 10 minus 2. So that's actually very small displacement because it's in millimeters. If you check for vertical displacements, you're going to have a much larger displacement. Let's just format that so the displacement is actually going to be not scientific conditions. All right, so here in the center of your beam, you have the maximum displacement of 1.6 millimeters. So that displacement for a 3 meters beam span is actually really great. So probably the previous section that we have chosen, it was actually really adequate for the loading conditions. Okay. So this is one example of how you can actually assess structures and do the pre-design phase. And the Ftool is actually an amazing software, and I during my undergraduate course and now as a professor, I use that for my students so they can learn. This software is free, as I said before, and you can use it to do assignments. I told you guys already that I'm also a structural engineer and also a engineer professor at the University Center of Brasilia. So I recommend the software to be used in undergraduate and even graduation courses. I hope you liked it. This is a small video. I believe that I'm not taking too much of your time, but I'm going to let the links below so you can check the software, and if you have any questions, you can email me. My university email, it's this one, yuri.cesareno@ceub.edu.br. You can email me if you have any questions on that matter. And I hope you liked it. So if you want to see more content like that, please comment below. Don't forget to subscribe in our channel. And if you check, there is also some other videos that we have posted there related to fire development, corrosion in steel structures. You also will see videos of structural analysis in our channel, but they're all in Portuguese. So if you want to see any of those videos in English, just let me know and send me an email. We are going to be a pleasure to hear that. So yeah, I hope you liked it and have a great day.